Good morning, dear students. So in the previous class, we were discussing about the effect of substituents, right, on the acidity of carboxylic acid. So we have seen how a electron withdrawing group, when it is attached to a this what carboxylic acid group, okay. So what will happen? The acidity of carboxylic acid will increase, right? We have seen. So these were the series. So please remember the series. Okay, so these are the electron withdrawing group. Okay, and this is arranged in the increasing order of acidity. Okay, so depending upon this, we have seen four cases, right? How it will affect. Then we have discussed about electron donating group. So electron donating group, when it is present to a carboxylic acid chain, what will happen to acidity? Acidity of the carboxylic acid will decrease. Okay, due to plus I effect. In electron withdrawing group, when electron withdrawing group is attached, then carboxylic acid acidity will increase due to minus I effect. Okay, so based on this also we have discussed. Okay, so we have seen the things. So because of the presence of the groups like your alkyl group, alkoxy group, okay. So what will happen if the this what it will decrease, okay. So electron donating group such as alkoxy group, okay, alkyl group, what will happen to the carbo acidity? It will decrease, okay. Then we are discuss about the formation of this. Okay, so the reaction involving the cleavage of COH bond, right? In that we have discussed the formation of anhydrides, how anhydrides are formed. Then the very important reactions, that is esterification reactions, how esterification reactions are found. So that also we have discussed, right? So these was the important. I said it to mark it for 2 marks. So when carboxylic acid reacts with alcohol in the presence of acid, in the presence of acid as a catalyst to form esters. Okay, so this is about esterification reaction. So this we have discussed. Then today we are going to see the other reactions. Okay, so the third reactions in which we are seeing the cleavage. So these are the reactions which comes under cleavage of COH bond. Okay, so the breaking of bond takes place at. Okay, so here are the reactions involving the cleavage of COH bond. So here the breaking of bond takes place here. Okay, COH. So let us see. So the hydroxyl group of this carboxylic acid, it behaves as what is it behaves like that of alcohol. Okay, and it can be easily replaced by a chlorine atom by heating or by treating it with PCl5, that is phosphorus pentachloride, phosphorus trichloride, and thionyl chloride. So these are the different reagents. So by treating it with this, so your OH group, okay, it can be replaced by your Cl. So these are the reaction. So when you treat your carboxylic acid, when you treat your carboxylic acid with your phosphorus pentachloride, you will get what? You will get a acid chloride. Okay, you will get a acid chloride and POCl3 plus HCl as a byproduct. Then when you treat your so we have taken here three molecules of carboxylic acid. When three molecules of carboxylic acid reacts with phosphorus trichloride, okay, phosphorus trichloride, you get again three molecules of acid chloride. So all the OH groups of the your carboxylic acid are replaced by Cl. So the breaking of bond takes place where? At COH, okay, and you get H3PO3. Next reaction, when you have a carboxylic acid and you treat it with thionyl chloride. Okay, so this is thionyl chloride. What you are going to get? Again, acyl chloride or acid chloride plus SO2 gas and HCl gas is liberated. So both these are gases. So in this, the acid chloride which is formed, okay, it will be in large amount. Okay, it will be in large amount. Why? Because the gases are escaped. So we can easily get the product. Okay, there is no need for any further separation, right? Because both the byproducts are gases. So gases will escape and we get the acid chloride. Okay, and so the yield will be more. So your base is used, okay, like pyridine. So this is an important reaction. So carboxylic acid, when it is treated with thionyl chloride, okay, in the presence of pyridine, will give you acid chlorides and SO2 gas, and your HCl gas is liberated. Okay, so please note it down. So let me give you example. If I take this, so this is what? This is acetic acid. So suppose I have a acetic acid. I treat it with what? Thionyl chloride in the presence of pyridine. What will be my product? What will be my product, students? Thionyl chloride, acetic acid in the presence of. So what will happen? Only your OH group. So you will get CH3, C double bond O, Cl. Okay, your OH group will be replaced by Cl plus SO2 gas and HCl gas will be liberated. Okay, so these are the gases, it will escape out. So you will get a acyl chloride. What you will get? You will get a acyl chloride. Sorry, acetyl chloride. Okay, acetyl chloride. Acetyl chloride. Fine. So like this, these are the reactions with phosphorus pentachloride, phosphorus trichloride, and thionyl chloride. Okay. Next is reaction with ammonia. Very important reactions. Important. Mark this important. 2 marks question. Okay. So here what we are going to do. So carboxylic acid is reacted with ammonia. What is ammonia? NH3. Okay. To give you ammonium salt. This ammonium salt, so carboxylic acid, okay, what we are going to do, we are going to treat it with ammonia. With this, what we are going to get? Ammonium salts. We are going to get ammonium salt. This ammonium salt, we are going to heat it, okay, and then at high temperature, and what we are going to get? Amides. Okay, we are going to get amides. So remember this. So carboxylic acid, when it is treated with ammonia, it gives you ammonium salt. So when you are heating it at high temperature, you get amides. What you get? You get amides. Okay. So here, so if I write it generally, so RCOH plus NH3, okay, you get ammonium salt. So this is a reversible reaction. Okay, reversible means what? It can undergo forward and backward reaction. So like this will be the arrow. So what you'll get? RCOO. So your H will be replaced by NH4 plus. Okay, NH4 plus. So this is my ammonium salt. This is my ammonium salt. Okay, so this is my carboxylic acid. Carboxylic acid. I'm going to treat it with ammonia. Okay, what I'm going to get? Ammonium salt. This ammonium salt, I'm going to heat it at high temperature. So when there will be heating taking place, so from this molecule, water molecule will be lost. So see, if water molecule is lost, what will be the product? So the product will be RC double bond O N H2O. So H2. Okay. So this will be my product, amide. Is it clear? Is it clear? So from this, okay, from this session, what will happen? H2O will go out. So when H2 will go out, what will remain? R C double bond O NH2. Is it clear? So this is the reaction with ammonia, very important. So carboxylic acid, you have to react it with ammonia. What you will get? You will get a ammonium salt. This ammonium salt, when you heat it at high temperature, so from that ammonium salt, water will be lost, and you are going to get a amide. Okay, you are going to get a amide. So let us see examples. Is it clear? So very important. 2 marks question. How carboxylic acid reacts with ammonia. So with ammonia, it forms ammonium salt. This on further heating at high temperature will give you amide. Okay, we'll get a amide. Okay. So let us go for the examples now. So first is acetic acid. So here is the first example they have given. So let us see. So acetic acid is there. Okay, so acetic acid CH3 C double bond O OH. Okay, so this is what acetic acid. So this acetic acid, I'm going to treat it with ammonia. Ammonia. What I'm going to get? OH will be replaced by, H will be replaced by your NH4 plus. So you will get a ammonium acetate. You will get a ammonium acetate. Now this ammonium acetate, when you heat it, so when this ammonium acetate, when you heat it, what will happen from this? Your H2O will go. Okay. So what you will get? CH3, C double bond O, okay, NH2. So you'll get a acetamide. Okay, you will get a acetamide. So this is a amide. So acetamide. So what will happen? So this is called as amide group. So R C double bond O NH2. So this represents what? This represents amide. Amine is what? RNH2. So this is amines. Right. Amide is what? R C double bond O NH2 is your amide. So remember this, don't get confused. So different functional groups, okay, how these are represented. Fine. So this is a amide and this is a amine. Fine. So one more example. Next example, you all tell me the answer, okay? So let me clear this. Okay. So let me take a benzoic acid, COH. So this is my benzoic acid. So this benzoic acid, I'm going to treat it with ammonia. I'm going to treat it with what? Ammonia. So it will go a reversible reaction. What will happen? Your hydrogen will be replaced by NH4 plus. So COO NH4 plus. Okay. So what you got? You got a ammonium benzoate. Ammonium benzoate is the salt. Okay. Now this ammonium benzoate, when you heat it, there will be loss of water molecule. What I'm going to get? I'm going to get C double bond O NH2. So this is benzamide. This is what? Benzamide. Is it clear? Is it clear now? Are the examples clear? Very important. 2 marks question. Very important. Is it clear? Now here, so this is with respect to one carboxylic acid, right? Now here in this reaction, okay, third example, you can see there are two carboxylic groups. Right, there are two carboxylic group. So for two carboxylic group, you require what? You require 2 moles of ammonia. You require 2 moles of ammonia. So that at each side, they will form ammonium ion. Okay, let me show you. Suppose, so this is your compound. Okay, so here, so two carboxylic acid groups are there. Right. So here two carboxylic acid groups are there. So to form the ammonium salt, now what I require? I require 2NH3. Okay, 2NH3. So 2NH3, what will be the product obtained? So it will be COONH4 plus COONH4 plus. So this is plus, this is minus, minus and plus. So this is what? So this is phthalic acid. This is phthalic acid and the name of this is ammonium phthalate. Ammonium phthalate. Okay. Now this phthalate, again we are going to heat it. After heating, so from here one water molecule will be lost. So from here one water molecule will be lost. From here one water molecule will be lost. So 2 moles of water molecule will be lost. So what you'll get? So C double bond O NH2, C double bond O NH2. Okay. Now again, so this is a thalamide. This is what? Thalamide. Okay, you get a thalamide. Now this thalamide, if you heat it, again if you heat strongly, okay, if you heat strongly, so what you are going to get? From here, your NH3 will go. Okay, your NH3. So from here one, so NH2 and here one H. Okay, so here one H will go. So this is NH2, right? So from here one H will go. Let me represent like with that color only. NH2. NH2, right? So from here one H will go. So what it is? Minus NH3. So when you heat it more strongly, what you are going to get now? You are going to get benzene ring, C double bond O N, C double bond O N H. Okay. So this is the uh, pipe. Okay. So this is thalamide. This is thalamide. This is thalamide. This is what? Thaliamide. Okay. So this is thalamide. So this is about your reaction with ammonia. These are the reactions with ammonia. Okay. So how the ammonia reacts with your carboxylic acid. So what will happen? It will form a salt that from that salt, if you heat it strongly, what will happen? Water molecule will be lost and you will get the respective amides. Is it clear? Are this reaction clear?
Yes, ma'am. Ma'am.
Okay. So this is about your reaction with ammonia. So let us go for the next one. Next is reaction involving COH group. Okay. Reactions involving COOH group. So this is third set of series. Okay, third set of series. Okay. So now reaction involving COH group. First one is the reduction. First one is the reduction. So what we are doing? Carboxylic acid is there. This carboxylic acid, we are going to react it with lithium aluminum hydride. Okay, lithium aluminum hydride. So lithium aluminum hydride is a reducing agent. Okay, so it is a reducing agent. So what we are doing? We are doing reduction. Okay, or we can use diborane, B2H6. It is called diborane. So we can use either lithium aluminum hydride or we can use diborane. Will give you primary alcohol. What it will give you? Primary alcohols. Okay, you will get a primary alcohols. So upon reduction, so what is happening here? COOH group is converted into RCH2OH. So what is happening here? The reaction, there is a change in your functional group. So from your carboxylic group, you are going to get a alcohol group. So this is about your primary, this what? Reduction part. So if I give you example, okay, let me take acetic acid. Acetic acid reacted with lithium aluminum hydride, okay, in the presence of ether as a solvent and further hydrolysis, what you are going to get? You are going to get CH3, CH2OH. What I'm going to get? Ethyl alcohol. Ethyl alcohol. So what is happening here? there is a removal of oxygen atoms and addition of hydrogen. So this is occurring in your reduction reaction. Next important reaction is decarboxylation. Can anyone tell me what do you mean by decarboxylation, students? What is decarboxylation? What is decarboxylation? Decarboxylation means carboxy group is what? CO2 group. So there is a decarboxylation means loss of carbon dioxide. Loss of carbon dioxide. Okay. So when sodium salt of carboxylic acid are heated, so you have to take a sodium salt of carboxylic acid. Okay, and you have to heat it in soda lime. What is soda lime? So remember this also very important. What is soda lime? Soda lime is NaOH, okay, plus calcium oxide in the ratio of 1:3. So this is the ratio. Okay, it is a ratio of 1:3, that is 3:1. Okay, 3:1 or 1:3. So this is the composition. Okay, so you have to take what? You have to take soda lime. Soda lime. So what you have to take? Carboxylic acid. Carboxylic acid. What will happen? The sodium salt of carboxylic acid, which are heated with soda lime. Okay, soda lime is NaOH plus calcium oxide. What will happen? They will lose a molecule of carbon dioxide. Okay, and this reaction is called as decarboxylation reaction. This reaction is called as what? Decarboxylation reaction. So RCOONA. So this is a carboxylic salt, sodium salt of carboxylic acid plus NaOH in the presence of calcium oxide. So this is your, you're going to heat it with the presence of soda amine and you're going to get a hydrocarbon plus Na2CO3. So carbon dioxide gas will be escaped out. So what you're going to get? I'm going to get a hydrocarbon. Suppose, let me give you example, CH3COONA. So this is a sodium acetate. This is what? Sodium acetate. So sodium acetate, I'm going to react it with NaOH in the presence of calcium oxide, heat it. What I'm going to get, students? What I'm going to get? So I'm going to get byproduct as Na2CO3 plus CH3, and this converts as one more H, so it becomes CH4. Okay, it becomes CH4. So you get methane. You get methane. Okay, so this is your what? Decarboxylation reaction. This is your decarboxylation reaction. Okay, so decarboxylation very important. Mark it as important for 2 marks. Mark it important for 2 marks. Decarboxylation reaction. Okay, fine. Let us go for the next one. Halogenation. So this is the fourth part of reactions. That is substitution reaction. Substitution reactions in the hydrocarbon part. In the hydrocarbon part. First one is the
Excuse me,
halogenation.
ma'am.
Yes.
Ma'am,
Yes.
in reduction part, ma'am, will use dry ether or only ether, ma'am?
We use
Dry ether or only ether?
ether and dry ether are one only. Okay. Dry ether is one only.
Okay, ma'am.
Okay. So next is we are seeing the substitution reaction in the hydrocarbon part. Okay, substitution reactions in the hydrocarbon part. So first one is the halogenation. Halogenation means what? We are introducing a halogen. We are introducing a halogen in the hydrocarbon part. So important, mark this also important. Important name reaction. So this is Hell-Volhard-Zelinsky reaction. It is called as HVZ reaction. So there can be a question, explain HVZ reaction or Hell-Volhard-Zelinsky reaction. Okay, with an example for 2 marks. So this is a 2 marks question. Explain Hell-Volhard-Zelinsky reaction with an example. Okay, so what is happening here? So the carboxylic acid having alpha hydrogen. So this is a carboxylic acid. So this is your alpha carbon. So to this, what is present? Two hydrogens are present. So there is what? There is a alpha hydrogen present. So carboxylic acid, which is having a alpha hydrogen. So we are going to treat it with your halogen, that is X2. Either you can use a chlorine or you can use bromine. Okay, your X will be either Cl2 or Br2 in the presence of red phosphorus. So red phosphorus we are going to use, which we are going to get a alpha halo. So at this alpha carbon, what is happening? One of the hydrogen will be replaced by a halo group. Okay, what is going to happen? One of the hydrogen atom will be replaced by what? Will be replaced by your halogen atom. Okay, so this reaction is called as Hell-Wohlhard-Zelensky reaction. What it is called as Hell-Wohlhard-Zelensky reaction. So carboxylic acid having an alpha hydrogen are halogenated at the alpha position. Okay, so what we are going to do? So the carboxylic acid, we are going to treat it with the X2, that is halogen in the presence of red phosphorus. Okay, so what will happen? One of the hydrogen atom will be replaced by your halogen atom. So it is undergoing a alpha halo carboxylic acid. It is going to form what? Alpha halo carboxylic acid. So this name reaction is called as what? Hell-Wohlhard-Zelensky reaction. So this name reaction is called as Hell-Wohlhard-Zelensky reaction. So what is happening at the alpha hydrogen? Okay, you can see here. Okay, add this alpha hydrogen. So I can write like this H2. Okay, so what is happening? So this is your carboxylic acid, this is your alpha hydrogen. Okay, so your hydrogen atom will be replaced by your halogen atom. What is the reagent? X2 in the presence of red phosphorus followed by hydrolysis. Okay, so this is your Hell-Wohlhard-Zelensky reaction. Important for 2 marks. Very important for 2 marks. Mark this important. Let us take an example. Suppose I have CH3, CH, HCOOH. So this is what? Again, acetic acid. So you also, what you do, practice it with the simplest example. Okay, keep one example only. Now, when you are discussing about carboxylic acid, you take the simplest acid, that is acetic acid. So with acetic acid, you can solve all the problem. So let me take the halogen as Cl2 in the presence of red phosphorus and followed by hydrolysis. Okay, followed by hydrolysis, what I'm going to get? CH3, CH, Cl, COOH. So what it is? Sorry, I've not taken acetic acid. It was ethanoic acid. Okay, let me take acetic acid only. Okay, let me take acetic acid. That was ethanoic acid. Okay, so this is our acetic acid. So what will happen? So this is my alpha carbon. So one of the hydrogen will be replaced. So by Cl. Okay, then I'm going to get COH. So what it is? It is a chloroacetic acid. Chloroacetic acid. So this is acetic acid. Okay. So I had taken ethanoic acid. So acetic acid, I'm going to treat it with Cl2 in the presence of red phosphorus and water. We are going to get a chloro. So one of the hydrogen will be replaced by your Cl atom. So this is a chloroacetic acid. Understood? So this is the reactions involving substitution reaction. Okay, we are substituting at the hydrocarbon part. So one of the hydrogen is replaced by what? Your chlorine atom. Okay, one halogen is introduced. So this is alpha halocarboxylic acids are formed, and this name reaction is called as Hell-Wohlhard-Zelensky reaction. Okay. Next question. This ring substitution. Next, we are going to see the ring substitution. Okay. So aromatic carboxylic acid, they undergo electrophilic substitution reactions at the ring. So what will happen? Aromatic carboxylic acids are there, no? So they will undergo a ring substitution reaction. Okay. electrophilic substitution reaction at the ring. So whatever the COH group is there, okay, on the because of the presence of the COH group, whatever the incoming electrophile is there, it will be directed at meta position. It will be directed as meta position, okay, and therefore further it will deactivate the benzene ring. Now what we are doing in the first, we are doing the nitration. The first is our nitration. What is nitrating agent? Concentrated HNO3 and concentrated H2SO4, which is the nitrophile, electrophile. It is nitronium ion. Okay, NO2 plus, which is the electrophile generated from this nitrating mixture. It is nitronium ion. So because of this presence of carboxylic acid, the nitronium ion is the electrophile which is directed to the meta position. So it is a 1,3 position. Okay. So it is metanitrobenzoic acid, metanitrobenzoic acid. So nitrating mixture, what is nitrating mixture? Nitrating mixture consists of concentrated HNO3 and concentrated H2SO4. Okay, which is a electrophile generated, it is nitronium ion. So the incoming electrophile will be positioned to meta position. So you are going to get this product. Okay. So this is our first ring substitution reaction, that is your nitration. Next we are going to see a bromination. Next, we are going to see a bromination. So in bromination, what is the reagent used? Br2 in the presence of FeBr3. Okay, Fe2Br3. So what is the this? It is Br plus. So the electrophile generated is Br plus. So the incoming electrophile will be what? It will be positioned at the meta position. Okay. So incoming electrophile, it will be directed to meta position. So what is the name? It is metabromobenzoic acid. Metabromobenzoic acid. Got it? So your aromatic, this what carboxylic acid, they do not undergo Friedel-Crafts reaction. Okay, they do not undergo Friedel-Crafts reaction because carboxylic acid is a deactivating group. Okay, and the anhydrous AlCl3 will get bonded to its carboxyl group. So because your this what COH group is what, it is a deactivating group. So the for Friedel-Crafts reaction we use anhydrous AlCl3 and all, right? So when we use that particular catalyst, it will react at the carboxylic group. So we are only doing nitration and bromination. So these are the two name reactions which we are going to do on the aromatic carboxylic acid. Is it clear? Is it clear up to here?
Yes, ma'am.
Okay. So these were the reactions. Okay, that is the substitution reactions in the hydrocarbon part. Okay. Last part. Okay, what are the uses? So we have seen the uses of aldehydes and ketones. So, okay, so let us see the uses of carboxylic acid. So hexane dioic acid. Okay, it is used in the manufacture of nylon 66. So nylon 66 is a polymer. Okay, so to manufacture this polymer, we are going to use hexane dioic acid. Okay, hexane dioic acid. Then esters of benzoic acid are used in perfumes. Okay, perfumery means for perfume preparation, esters of benzoic acids we are making use of. Then sodium benzoate. Okay, sodium benzoate, it is used as a food preservative. So for preservation of food, okay, we are going to use sodium benzoate. So these are uses. Then higher fatty acids are used in the manufacture of soaps and detergent. So the fatty acids, okay, higher fatty acid means the number of carbon chain will be more. So whichever the carbon chain will be more, so these fatty acids where we are using in the soaps and detergents, okay, the soaps and detergents which we use. Then methanoic acid, that is your formic acid. It is used in your textiles. Okay, textiles means what? In the clothes. Okay, for manufacturing of clothes. Then your leather. Okay, then your dye. Okay, So in this, you are going to use your methanoic acid or the formic acid. Then ethanoic acid, or it is the acetic acid, ethanoic acid or the acetic acid. Where it is used as a solvent. It is used as a solvent. And vinegar, okay, it is used as a vinegar in food industry. So these are some of the uses of what? Of your carboxylic acid. Okay. So, this completes your chapter aldehydes, ketones, and carboxylic acids. Okay, so we finished this chapter, that is aldehydes, ketones, and carboxylic acid. So I have uploaded the notes. Okay, please go through the notes of aldehyde, ketones, and carboxylic acid. Fine. So any doubts up to here? So yes.
No, ma'am.
Okay. So please, as I have been telling you, so please practice the name reactions. You have to practice it by writing the name reactions. Okay. If you find any difficulty, please ask. Okay. So because don't get confused, the name reactions you seem to be when I'll be explaining that time you will understand, but later you will confuse yourself. Okay. So please understand the things and then you practice. Don't blindly practice it. Okay. So from Monday, we are going to start with the next chapter, very important chapter, that is coordination chemistry. Okay, so don't miss the classes from Monday because coordination chemistry is very important chapter. Fine. So it is like a applied chemistry. Okay. Okay. Any others? Anybody have any doubts?
Ma'am, weightage of this chapter, ma'am.
Okay, just a second. 14 marks. 14. So this has a more, okay, 14, 1, 4. And the coordination compounds, which we are going to start from Monday, it has 12 marks. Okay,
Thank you.
fine. So no doubts, others, Harshita, Navneet, no doubts. Anything you want to ask, you can ask.
No, ma'am.
Okay, fine. So please practice the name reaction. If you find any difficulty at any point, you can come back to me anytime. Okay, I'll be there to help you out. Fine. So by this, we'll end the session here. Okay. So we'll meet on Monday with a new chapter. Fine. So till then, study. Okay, till then you can just practice the name reaction. Okay. Enjoy your holiday, Sunday. Okay, and come back on Monday. Fine. So have a good weekend. Bye everyone.
Bye, ma'am. Thank you, ma'am.
Yes, thank you.